Guys, let's look at the grade 11 types of forces. The types of forces, guys, you have to understand what is a force. Number one, the force is a push or pull, and a force is a vector quantity which has a magnitude and direction, and it's measured in newtons. So we're going to look at the types of forces now. So the types of forces, we have contact forces and non-contact forces. We have two types of forces. Let's look at the contact forces. When we talk about the contact forces, we talk about the forces like friction, normal force, applied force, and air resistance. But the main one that we're going to look at, we're going to look at the friction, normal force, applied force. So when I talk about the applied force, we're talking about the tension force as well. Now, those are the contact forces. And now, when we talk about the non-contact forces, the forces that occurs at a distance. So it's a gravitational force, electrostatic and magnetic field, and the magnetic force. Those are the non-contact force. They occur at distance. This one, there's a physical contact when that force occurs. Right? Now let's look at the normal force. What is a normal force? A normal force, its sign or its symbol. It's the capital letter N or it's the capital letter F with the subscript capital letter N. It's the normal force. Now, the definition of the normal force is very important to know it. Is the force or the component of the force in which the surface exerts on an object is in contact with and which acts perpendicular to the surface. So a normal force is a force which the surface exerts on objects in contact with and which is perpendicular. Let's look at this object. This object is lying on top of the table there. So the surface of the table is exerting a force that is perpendicular there. Perpendicular to the surface there. Do you see it's perpendicular? So we call this force that the surface exerts on an object. It's a what? It's a normal force there. And another force that is also parallel to the normal force is the gravitational force. So in this case, they're equivalent. The normal force and the gravitational force are equivalent but in opposite direction. It depends on what direction do you choose. So every time when an object it's on the surface, look at this object, it's lying on the surface there, but the surface is vertically. So there's a force that is acting. Let's say you're pushing a book against the wall, so that book is experiencing a normal force there. There is a normal force there in that direction. So it's the force that the surface exerts on an object. Even in an object that is on an incline there, which is there's the surface there, it's a steeper slope. Now this object is lying on that, so there is a normal force there. Normal force is always perpendicular to the surface there. Right, let's look at another force there. The other force is the frictional force. The frictional force, guys, it's denoted as small letter F there. Is denoted as a small letter F, is the force that opposes the motion of an object which acts parallel to the surface. So the force that opposes the motion of an object, it's a frictional force. Let's look at this diagram here. So this gentleman here is pushing this box or a crate or whatever the object is. So the motion of an object is going in that direction, but the frictional force that opposes the motion, it's going in an opposite direction all the time. Let's look at this gentleman as well, is pushing that block there. So the motion of the block is going there, and the frictional force that opposes the motion. So the frictional force that opposes the motion, it acts parallel to the surface. Now it's very important, there are two types of forces. The first one, it's not the first one, it can be the second one, is a static frictional force. So static, the word static means not moving. So it's a static frictional force. It's self-explanatory. It means it's a frictional force that deals with objects that are not moving. Now it says the force that opposes the tendency of a motion of a stationary object relative to the surface. So you must be able to define it in that way. That's the exam guideline definitions, guys. So this force is a force that opposes the motion of or a stationary object relative to the surface. So this gentleman, if you look here, is pushing this box in that direction, but the box is not moving. I'm going to explain it later why it's not moving. So there's a force that opposes the motion, which is there's an applied force in this direction. There's a static frictional force that is going there in the opposite motion. So that frictional force that is responsible for that object not to move is a static frictional force. Let's look at the second type of the frictional force. We call it, it's an FK. So guys, the static frictional force, its symbol, it's Fs, S for static, right? Now, and there's a formula. Let me give you the formula. The formula for the static frictional force is Fs max is equal to mu s times what? Normal force. What is mu s? Mu s is a description of the surface. Description of the surface. What do I mean about the description of the surface? How rough or smooth the surface is. The surface is, and always, guys, this is mu s. We call it, it's a mu s is a coefficient of static friction. That's the coefficient, and always the value, the mu s is must be less than 1 with no units. There are no units. What's the reason for them not to have units? It's a ratio, because it's a ratio of forces. So we know a ratio, right? So if we say mu s is equal to Fs max divided by the normal force. So it's a ratio between those two forces. Ratio, guys, when we talk about the ratio, it's a division. So another type of force is the kinetic frictional force. Kinetic frictional force, so its symbol there, or its sign, is Fk, is the forces that opposes the motion of a moving object relative to the surface. So when we talk about kinetic, we're talking about the motion, something that is what, in motion or moving. So if you look at this gentleman here, is pushing this object, and while it's pushing this object, it's pushing in that direction, there's a kinetic frictional force that opposes the motion while it's in moving. We call it, it's what, it's kinetic frictional force. So the formula for the kinetic frictional force, it's Fk is equal to mu k times what, normal force. I've shown you the normal force. So as I've mentioned, the frictional force, it's a force, it's measured in newtons, and this one, it's a coefficient. Again, this one is a coefficient of kinetic friction. The kinetic friction, it's a mu k, and it's less than 1 as well, with no units. So why it doesn't have units? It's a ratio as well between two forces, and it must be less than 1. And yeah, let's move. Let's look at this graph, as I've promised that I'll show you what's happening when an object is not moving. So when you're applying a force, okay, let's say an object is just sitting there. So when an object is sitting there without an applied force, so there will be no friction there. There will be zero friction there. So when there's an applied force there, and the applied force there, if it's equal, the applied force, if it's equal to the frictional force, the object is not going to move. And even if you increase it, the applied force, the object is not going to move. The frictional force is going to increase as well. Do you see? The frictional force increases as well. So, in order to move this object, there's a maximum static frictional force. As I've mentioned, that the only force that is responsible for that object not to move is a static frictional force. So it has to reach a maximum static frictional force, or the force that you're exerting, it has to overcome the static the maximum static frictional force. So as soon as you hit that threshold there, and then that means an object will start to move now. So it will have the kinetic energy. So this means that your force applied, it must be greater. It must be greater than the what? The static frictional force. That's when the object will start to move. As long as the force applied is still equal to the Fs, the object is not going to move. Not going to move. There. Right? So that graph in the nutshell, it shows that. Alright guys, let's look at another type of contact force, which is the force applied. Force applied is denoted as capital letter F, or F with the subscript capital letter A. A person or an object exert a force on another objects or a person. So the force applied is a force that is exerted by a person or an object to another object. If you look at this object here, there's a force that is exerted there. We call that force as a force applied. If you look at this object here, there's a force that is exerted at an angle on that object. So we call that it's a force applied. There's a force on that object in that direction there, so we call that it's a force applied, guys. And there's another type of the force applied, we call it it's a tension force. A tension force, it's capital letter T or FT, subscript T. When a cable or rope is pulled, a tension is exerted. Guys, a tension force is very important. It's part of the applied force. It's an applied force through a rope or through a cable. So if you look at these two objects, they're exerting a force on each other. So this force that they exert on each other, it's a tension force. It's a force that they exert on each other through a rope. And also, if you're looking at object 2, there's a force applied there on object 2, and it only applies on mass 2. So if you're looking at these two objects, they are a system, guys. There's a tension between them. So it's a force that is applied through a rope. And also these two objects that are on an inclined surface, there's a tension force between them. So the tension force between them, it's Newton's third law. So the tension force that they exert on each other, it's equal in opposite direction. Even there it's equal in opposite direction. So if you look at these two masses, they are attached by a rope or a cable there. So there's a tension force between. So the exerter is exerting the tension force between them, but in opposite direction. Now let's look at the only contact force that we're going to look at this stage. So this contact force, we call it's a non-contact, the non-contact force, it's a gravitational force. So its symbol, it's Fg or W, is the force that the earth exerts on any object near its surface. So it's a force that the earth exerts, on an object. Now if you look at this, there's an object on top of the table. So there's a gravitational force that is acting there. It's W. It's acting downwards always, guys. Even there's a gravitational force. Gravitational force is acting down. Even there's a gravitational force in that object on an incline. And this gravitational force here, it has components, which is there. It's Fg perpendicular. And we're going to have Fg parallel. So it has two components. So this Fg, which is the weight, guys, when we talk about the Fg, the gravitational force, it's also the weight. And you must be able to distinguish between the weight and the mass, right? So it has two components there, the Fg perpendicular and Fg parallel. And Fg parallel is always down the slope. And the formula for the gravitational force, it's Fg is equal to mass times gravitational acceleration, and it's measured in what? In newtons. Guys, it's very important to differentiate. So the weight, when we talk about the weight, we're talking about the gravitational force. When we talk about the mass, guys, the mass is measured, okay, the weight is measured in newtons, it's a force, but the weight is measured in kilogram. So the mass is an amount of what? Of matter. It's an amount of matter when we talk about the mass. So there's a difference between the two. The other, it's an amount of matter. The other, it's the gravitational force, and it's very important that. Okay, let's leave it there, guys.